Hello. Okay, please specify how long key should valid now. Zero key does not expire slash and key expiring X days and weeks. Let's use N. N is invalid. Should we write like this? In 3 days it should expire. No, it's invalid. So how to hello? Hello, mic testing, mic testing. Oh, I see. Yeah, okay. Hello, hello, hello. Hello, 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 hello. Okay. How it works? Please specify how long the key should be valid. We have selected. Uh, let's just write 0. It does not expire. Yes. GNU PG needs to construct a user ID to identify your key. Let's say stratgos. Okay, email address stratgos @tryhackme.thm. Let's use comment. Let's say comment would be, hey, we have selected this user ID, this. Okay, let's use Q. Quit. Key generation cancelled. What the hell? You may need to use GPU to decrypt files in CTFs. Private keys can be protected with passphrases in a similar way that we protect SSH private keys. If the key is Passphrase is protected. You can attempt to crack it using John the Ripper and GPG to John. The key provided in these tasks is not protected with the passphrase. The main page for GPG can be found online here. Practical example. Now that you have your GPG key pair, you can share the public key with your contacts whenever your contacts want to communicate securely. They encrypt their messages to you using your public key. To decrypt the message, you will have to use your private key. Due to importance of the GPG keys, it is vital that you keep a backup copy in a secure location. Let's say you got a new computer. All you need to do is import your key. You can start decrypting your received message again. You would use GPG import backup.key to import your key from backup.key. To decrypt your message, you need to issue GPG slash GPG dash dash decrypt confidential. What is this, bro? Dash message dot GPG. Mm. Use GPG to decrypt the message in slash public key. What secret word does the message hold? So what did I do for GPG slash utility I hope this works. Mm, GPG decrypt password decrypt unknown system is a directly decrypt message for unknown something something. Let's say what this message dot gs control C Let's just decrypt. Okay, slash search search dot conflicting commands. What does it mean? What secret word that the message hold? Encrypted with RSA key. ID is something something. Public key decryption failed. No secret key. Something. So decrypted with encryption failed. Let's okay, GPT. Public cryptography. Let's just use this. Okay, now write GPG slash decrypt. Decrypt this talks slash. The secret word is pineapple. Fine. Let's go. Okay. Learners who space session. Okay. Hashing basics. Okay. A hash value is a fixed size string. Okay, I think. Okay, consider the scenario where you just downloaded a 6 GB file and want to whether the copy identical to the original file, bit by bit. How would you do that? Or if a good Samaritan handed you this 6 GB file on a USB memory drive, how can you be sure it is identical to the file you want to download? The answer to both of the questions lies in comparing the hash values of two files. If two hash values are equal, you can say with very high certainty that the two files are identical. But what is a hash value? The hash value is a fixed size string or character that is computed by a hash function. A hash function takes an input of an arbitrary size and return an output of fixed length. That is a hash value we will cover various exciting and clever uses of hash function and values in the room. Note about terminology. We favor the terms hash function and hash value. However, we occasionally use the word hash as a verb to mean to calculate the hash value. Moreover, we occasionally use the word hash by itself as a noun to refer to the hash value. Okay, so room prerequisite. This room is the third three directive about cryptography because we will reference the topics in the previous two rooms. It is recommended that you finish this last two rooms before attending this. Okay. Upon the completion of this room, you will learn about hash function and collisions, the role of hashing in authentication system recognizing store hash value, and cracking hash values, then use of hashing for integrity protection. To follow along, first let's start the lab machine by pressing start lab machine. The machine will start in split screen and displays this. You can access the lab using SSH at the IP address of this. We are at this IP address, right? So using the following credential. Okay, let's begin. No answer needed. Let's learn about hash function. Hash function. Okay, hash function. Hash. Okay. Hash functions are different from encryption. There is no key and it's meant to be possible. And it's meant to be impossible to go from the output back to the input. A hash function takes some input data of any size and create a summary digest of the data. Hash functions are different from encryption. There is no key and it's meant to be impossible. A hash function takes some input data of any size and create a summary or digest of that data. The output has a fixed size. It's hard to predict the output for any input and vice versa. Good hashing algorithm will be relatively fast to compute and prohibitively slow to reverse. That is, go from the output and determine the input. Any slight change in the input data, even a single bit, should cause a significant change in the output. Let's check an example. In the terminal below, we can see two files. The first contains the letter T, and while the second letter contains the letter U. If you check the T and U in ASCII table or using hexadecimal, you will notice that the two letters differ by single bit. So consequently, the following two files differ by a single bit. However, if we compare their MD5 message digest algorithm 5 hashes, there are SHA1 secure hash algorithm 1 hashes, or there SHA256 hashes. We will notice that they will entirely different. We recommend that you try the command below yourself. The files are located in hashing basics tags 2. Okay. Uh, la, 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 la. Let's say cat 2, cat 2 here. Okay. Can we go there now? It's a directory. We are right now in user. Then let's go to cat slash cat hashing basics. Hashing basic is a directory. Oh my god, bro. Let's go to cat. Uh, Hashing basics. What is right? Basics. Tags. Slash 2. Why are we using cat? We can use this one, right? We can't use cat. Oh, sorry, my bad. Steady hashing basics. Can we go there now? Okay, right now we are here. Okay, let's go to ls. Let's write ls now. It will show this. Let's go to, what does it say? Tasks 2. Tasks 2. Oh, we can't go there. Oh, I wrote it wrong. TSK tasks slash 2. Is this fine? Yeah, it is fine. Let's say ls. Now there is a file 1 text and file 2 text. Now we need to compare them. So let's write cat file 1.txt. Okay, I think, what did I do? Is it wrong? Oh, it's already answered. It's written here. Okay, so okay, let's compare the other one. Cat file to txt, I think. Okay, it came as a u, but first one came as a t, then second one come as a u. So let's, now we need to use hexdump. Let's use hexdump then. Hexdump slash c file 1.txt. It will show his hexadecimal. So let's use hexam again on the second file, or slash c file 2.txt. Okay, hexdump. Now we can see the difference here in the sky. It come as a 54, it come as a 55. Okay, now he is using md5 sum. What does it do, bro? I forgot it already. Is this correct? Okay. Let's just remove this. Oh, I removed the wrong one. Something like this. What does it do? I forgot about this already. So this command used to do something. Okay, let's. Oh, it's showing the. Oh, sorry. It's showing the. It's, what do we call it? MAC address. No. Hashing. It's showing the hashing value. Oh, it's showing the hashing value. Uh, The output of a hash function is typically raw bytes, which are then encoded. Common encoding are base 64 or hexadecimal. ये सब encoding techniques है. So MD5 sum या SHA-1 sum, SHA-256 sum, SHA-512 sum produce their outputs in hexadecimal format. Remember that hexadecimal format prints each raw byte as 2 hexadecimal digits. So let's there we can see that let's use the other technique too. Sesam dot this I think it's like this. dot txt.
Qual ثانية؟
escolhi già saremo nel top 6.
Riesco ثانية أصلا.
Nikes yapmasallo. Ana queria delle tonga samela ngala.
Lei kami yezollo de kana haya me yistas. Ay.
Nas sam nasi sam silence. Nas sam ki kes megi nas nis kolet nis bukhata ne ko salar ya nas kolet achin.
Sen ne yalnız kolettin? Sen ne yapıyorsun? Şimdi cari.
Okay. Okay, so why is hashing important? Hashing plays a vital role in our daily use of the internet. Like other cryptographic functions, hashing remains hidden from the user. Hashing helps protect data integrity and ensure password confidentiality. So consider this example of hashing. Consider this example of hashing is used to protect your cybersecurity. When you log into Tryhackme, the user uses hashing to verify your password. In fact, as per good security practice, a server does not record your password, it records the hash value of your password. So whenever you want to log in, it will calculate the hash value of password you submitted with the recorded hash value. Similarly, when you log into your computer, hashing plays a very role in verifying passwords. You interact more indirectly with hashing more than you would think, and almost daily in the context of password. Let's learn about hash collision. A hash collision is when two different inputs give the same output. Hash values are designed to avoid collisions as best as possible. Furthermore, hash functions are designed to prevent an attacker from being able to create, that is, engineer, a collision intentionally. However, because the number of inputs is practically unlimited and the number of possible outputs is limited, this leads to a pigeonhole effect. So two different inputs होते हैं यहाँ पे हैश फंक्शन जो है डिज़ाइन किया गया है कि ताकि हम इन क्लोजन्स को अवॉइड कर सके एज बेस्ट एज पॉसिबल। तो इसका मेरा मतलब क्या है, हैश फंक्शन जो है वो डिज़ाइन किया गया है कि कोई अटैकर टू बीइंग एबल टू क्रिएट और engineer a collision intentionally. So however, because the number of inputs is practically unlimited and the number of possible output is limited, then this leads to a pigeonhole effect. Okay, let's see what does this mean. As a numeric example, if a hash function produces a 4-bit hash value, let's say 4-bit, so we only have 16 different hash values, सही, क्योंकि 4 बिट है तो वहाँ से कुछ 16 पॉसिबल्स हो सकते हैं, हैश वैल्यू पॉसिबल है. So the total number of possible hash values is 2 number of bits. 2 power 4 is 16. The probability of a collision is relatively very high. हाँ सी आई सी इसका मतलब ये है. तो क्या करते हैं कि ऐसे सही सही. So the pigeonhole effect states that the number of items like pigeons is more than the number of containers. Yeah, it's like a pigeon hole principle. we learn in discrete mathematics. So some container must hold more than one item. सही बात है. In other words, in this context, there are fixed number of different outputs values for the hash function, but you can give it to any size inputs, as there are more inputs than outputs. Some input must inevitably give the same output if you have 21 pigeons and 16 pigeonholes. So how will you place them, the 21 pigeons in 16 pigeonholes? So some of the pigeons are going to share the pigeonholes. सही बोला. So consequently collisions are unavoidable. तो हम इसको avoid नहीं कर सकते. So collision होगा ही होगा. So however, a good hash function ensures that the probability of a collision is negligible. So let's see what this MD5 and SHA1 have been attacked and are now considered insecure due to the ability to engineer hash collisions. However, no attack has yet given a collision in both algorithms simultaneously. So if you compare the MD5 and SHA1 hash, you will see that they are different. You can view the MD5 collision example on the MD5 collision demo page. Furthermore, you can read the details of SHA1 collision attack at Shattered. Let's see what are these MD5 collision. Uh, Published in February 22, 2006. Oh my god, last updated October 2011, bro. Oh my god. It is now a collision in the MD5 cryptographic hash function. It is now well known that the cryptographic hash functions MD5 okay, has been broken. In March 2005, Zhao Yun and Hong Bu Yu of Shandong University in China published an article in which they describe an algorithm that can find two different sequences of 128 bytes with the name MD5 hash. One famous such pair is the following. Okay, some hash function, hash value here, and another hash value is here. So there are some red marks here. What does it mean? Each of these blocks has MD5 hash. Okay. Ben Lowry has a nice website that visualizes the MD5 collision. For a non-technical though slightly outdated introduction to hash function, see Steve Wright guide. Okay, let's see. As we will explain below, the algorithm of Wang and Yu can be used to create files of arbitrary length that have identical MD5 hashes, and that they differ only in 128 bytes somewhere in the middle of the file. Several people have used these techniques to create pairs of interesting files with identical MD5 hashes. Oh my god, what is this MD5 hashes, bro? Okay. Okay. Magnus Dam and Stefan Lux have created something in which one is a letter of recommendation and the other is a security clearance. Something क्या है इसमें देखते हैं क्या है. The following is an improvement of Dia's example which does not need a special extractor. Here are two pairs of executable programs. One pair runs on Windows and one pair on Linux. Say this one and this one. Okay, so this program must be run from the console. Here is what happens if you run them. So here run it md5 hello.exe. So it's showing this one. Uh, uh, when we just run this, it shows hello world. So what does that mean? When we run here, eraser.exe, this one, this program is evil, erasing hard drive 1 GB to be just kidding, nothing has erased. Okay. So the above files were generated by exploiting two facts: the block structure of the MD5 functions, the fact that Wang and Yu techniques works for an arbitrary initialization vector. To understand what this means, It is useful to have a general idea of how the MD5 function processes the inputs. Okay, so a given input file is first printed so that its length will be multiplied into 64 by it is done. Okay, okay. Can we put let's wait. Bro, this is getting complex and complex. Okay, so we are verifying your browser. Mm, 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 mm. Okay, so we are learning about hashing, hashing. Okay, okay, this one. Okay, what is the SHA-256 hash of the password.gpt file in hashing basic tasks 2? So let's see. Let's start writing commands now. Ls. Let's see. Okay, it's in the hashing basic. Okay, so let's go to hashing basic. Hashing basics. Hashing basics slash go to tasks 2. Okay, we are here now. Let's write ls again. Okay, there is a file. There is a two files and two text files and one password.gpg. So we need to now know what is the SHA-256 hash of the password.gpg. So let's write uh, how to write that, bro. Sh should we write in capital letter? SHA-256. Hmm. Wait. Let's first use hexdem. Oh, let's first see what's in the password.gpg. Password password.gpg. Okay. Oh my God, this is the value here. So we need to exit this, bro. How can we exit this? Control. Okay, now control that. This is there, bro. I think the so right now we need to find the SHA-256 hash value. Okay. So in order to know that we need to use this command. Okay, we need to use SHA-256. SHA-256. SHA-256 ISUM then we will use it on passport.gpg, right? So passport.gpg. I think this is right. Is this good? I think this is good. So oh, this is we got the hash value here, guys. So this is the hash value this image contains. So let's just copy. Oh my God, how to copy this? Okay, let's see. And it's correct, guys. What is the output size in bytes of MD5 hash functions? Let's see. Okay. Output size in bytes of the MD5 hash function. That's right. 64. No, the answer is incorrect. Output size of the MD5 hash function. I forget it already, bro. What is the output of MD5 hash function, bro? MD5. This one is MD5, okay? So if we see the MD5 size, okay, let's MD5 hash. Okay, oh, it's I think it's 16. Okay, if you have an 8-bit hash output, how many possible values are there? हमारे पास 8 बिट का ये है तो हमें क्या करना पड़ेगा? 2 पावर 8, 2 पावर 8 कितना होता है? तो 2 पावर 8 होता है 256. तो 256 आंसर आएगा इसका. So let's go to the next session. Hashing has many uses in cybersecurity. In this room, we will focus on two uses: password storage and data integrity. We refer to password storage when used for authentication. It is very important to note that this does not apply to password password manager. Sorry, where you must retrieve your password in clear text. On the other hand, authentication mechanism only need to confirm that the user knows the password, so they can be guaranteed access to the resources. Therefore, this problem differs from password manager. Okay. Stories of insecure password storage of for authentication. क्या होता है कि मोस्ट जो वेब एप्लीकेशन होता है वो उनको वेरीफाई करना पड़ता है यूज़र को पासवर्ड लगा के एट सम पॉइंट. तो स्टोरिंग दिस पासवर्ड जो होता है इन प्लेन टेक्स्ट इज वेरी इनसिक्योर सिक्योरिटी प्रैक्टिस. सो यू प्रोबेबली सी न्यूज़ स्टोरीज अबाउट कंपनीज दैट हैव डाटा लीक समथिंग समथिंग समथिंग. So we will visit the three insecure practice when it comes to password. Storing password in plain text. Storing password using depreciated encryption. Storing password using insecure hashing algorithm. So हमें क्या करना पड़ेगा? तो storing password in plain text. So quite a few data breaches have leaked plain text password. You are probably familiar with the ROQ.txt password list in Kali among many of the offensive security distribution. We know it, boys. Let's go ls ROQ.txt. So let's open the ROQ text file. Okay, we have, oh my god, bro, so many passwords here. So this password list came from ROQ, a company that develops social media application and widgets. So they stored their password in plain text and the company had a data breach. The text file contains over 14 million passwords. Look at this, guys, 14 million passwords. We can find roq.txt in the user shared word list directory. Okay, so it's still going on, bro. 14 million, oh my god, bro. So using an insecure encryption algorithm, Adobe Notable data breach was slightly different. Instead of using a secure hashing function to store the hash value of password, the company used a depreciated encryption format. Furthermore, password hints were stored in plain text, sometimes containing the password itself. Consequently, the plain text password could be retrieved relatively quickly using an insecure hash function. LinkedIn also suffered a data breach in 2012. LinkedIn used an insecure hashing algorithm. The SHA-1 stored user password. Furthermore, no password salting was used. Password salting usually refers to adding a salt, a random value to the password before it is hashed. So what is the 20th password in rockq.text? So let's see it. I think it will be. Okay, let's stop this now. Oh my god, bro, it's not stopping. Let's stop now. Finally, bro, you are so. Oh, we are on the K now. What the hell? Let's clear this, bro. Okay, let's rock you. Rock you.txt. Let's put an count to 20. I think it will be right. Ah, control set. Okay, it's already on P. I said 20, bro. Oh, it's so fast, bro. Let's just randomly write Qt, the most common password. Ah, it's good. Using hashing to store passwords. Uh, this is where the hashing comes in. What if instead of storing the password, you just store its hash? Well, you're using a secure hashing function. This process means you never have to store the user's password. And if your database is leaked, an attacker will have to crack each password to find out what the password was. There is just one problem with this. What if two users have the same password? As a hash function will always turn the same input and to the same output. So you will store the same password hash for each user. That means if someone cracks that hash, they gain access to more than one account. Yeah, it also means that someone can create a rainbow table to break the hashes. So what is a rainbow table, bro? A rainbow table is a lookup table of hashes to plain text. So you can quickly find out what password a user had just from the hash. A rainbow table trades the time to crack a hash for hard disk space, but it takes time to create. Here is a quick example to get an idea what is a rainbow table looks like. Let's see 02 something something something. This password. So website like CrackStation and hashes.com internally uses massive rainbow tables to provide fast password cracking for hashes without salts. Doing a lookup in a sorted list of hashes is quicker than trying to crack the hash. So protecting against these rainbow tables, okay? So let's clear this, bro. Okay, clear. To protect against rainbow tables, we add a salt to the password. The salt is a randomly generated value stored in the database. Should be unique to each user. In theory, you could use the same salt for all users, but duplicate passwords would still have the same hash and a rainbow table could still be created for password with the salt. The salt is added to either the start और किसी end पे ऐड किया जाता है उस salt को. तो इसका मतलब क्या है कि हमें different hashes और different passwords बन जाते हैं उससे. So you can find many good guys online that promotes best security practice when storing password. Please check if there is any standard you need to follow when storing password before adopting to consider one. Okay. Check the hash this using the rainbow table above. C1, 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 C1. This one in your pass. What the hell is this? Control C. Let's put it this here. Check. Correct the hash for using an online tool. This one. Okay, let's use hash.com. This is gonna be fun. Oh shit. What is this? Hash cracker. Something, 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 something. Is this the converter? Yeah, okay. We need to file here. We need to put file as a PK Pro. Shit. So let's just change this to another one. This one. Okay. Website. What does he do? हमें जाना है इस पे crack station. Let's use crack station. Okay. I'm not a robot. Okay, what we need to crack now? So we need to crack this thing. So if let's see what this gives. Let's use crack station. Okay, let's put this here. Ah, okay. Okay, now convert. Oh my god, bro, what is this? Traffic lights. Traffic lights, traffic lights, traffic lights. Here. This is a traffic light. Yes. Here also. There is no traffic light. There is this one. Verify. Okay, correct. Unknown. Oh my god, bro. Let's use. Let's use this website. Let's use this website. Let's put this our hash here and the captcha check. Where is that? Let's use what's GJU capital XKH. Submit and search. Found. What found? Oh, Tryhackme. It's answered Tryhackme, guys. Tryhackme. Okay, done. Okay, should you encrypt password in password authentication system? Should you encrypt in? Yeah. No. Check no. Okay, guys. So that's it for today. Today this stream is over. I'm gonna